Before you do, let me say quickly to the audience, I am the host of this webinar. My name is Alex Ibe, and I'm the Dean of Academics here at Weatherford College. And Jim Mellott is Professor of Geology here at Weatherford College. And then, of course, the topic today is climate change. So you are unmuted. We cannot see you. We cannot hear you. You can see us. But as soon as Jim begins to speak, I'm going to mute myself as well. And at about 35 minutes into his speech, I will unmute myself. That's a signal to him that we are at the 35 minutes mark. Then he can start wrapping things up. At about 45 minutes into it, we begin our conclusion on today's topic. All right? Thank you all. So Jim, it's all yours if you want to share your screen.
Thank you. Oh, okay. I guess it starts here. Oops, back one. When Scott proposed this meeting, I had thought of talking about probably the greatest scam from a meteorologist, climatologist standpoint that's ever been proposed to the human being, human society. This meme came forward of Al Gore acting as the Pope, telling Galileo that the science is settled and that the Earth is the center of the universe and the sun rotates. We know that's not true now. And the nice thing about being a hard scientist is you can say anything you want to in politics or anything else and in science, but if you don't have the data, nature will bite you in the ass. And what came about was the fact that I had looked at that, and then mid-February came around, and then last week, and I realized that what we were looking at in possible climate, which I will talk about here in the future, of why, isn't what we were expecting. At least we'll have a chance of living, not the doom and gloom that the politicians and the news media are talking about. One of the things in geology, which is interesting because we always talk about the key, James Hutton, uniformitarianism, the present is the key to the past. But we forget the other half of his quote, the past is the guide to the future. Most people, when they look at climate, vast majority, climate's what you expect, weather's what you get. Obviously, what this happened this winter. But to a climate scientist, really soon is a doctor of astronomy in Harvard, understanding climate requires an amalgamation of astronomy, solar physics, historical geology, geochronology, geochemistry, sedimentology, tectonics, paleontology, paleoecology, glaciology, climatology, meteorology, oceanography, ecology, archaeology, and history. You don't have to have a complete knowledge and be the professor of it, but you have to be understanding of it, reading it, and ask questions. One of the beautiful things of working in Weatherford College, we got a physicist and chemist, we can answer some questions. And biologists. But the Earth atmosphere, what's happening today, tells us nothing about the future. This schematic I show in my class of the basis of weather. But notice that what we want to talk about here is the three changes that come on a long-term frame. All the other things are minute daily changes. Solar radiation, the amount of sun drives everything. That's the only heat source that comes to the Earth. So the amount of absorbed is the key. What happens to that, the solar optical properties, atmospheric optical properties, we'll talk about now. They're going to change. They're changing right now. And the ocean flux. By the way, notice that little blue thing? That's the CO2, almost non-existent. So it's a cup of water in the ocean, even though polar bears know that. This is 600 million years of temperature and CO2. The temperature is varied basically between 12 degrees C and 22 degrees C over the geologic history. But CO2 has been all over the place, way high, way low. And the only time there's a correlation with CO2 and time temperature is when the CO2 is very low. We have cold temperature. CO2 could be very high, but we never get higher than 22 degrees because most of it's moderation by the ocean and many other things. But in what we see right now in historical geology and in climatology, there are a number of factors, at least 12 we know of, but these are the 5, or I should say 4 major and 1 minor factor cycle that we know exists today and we have good data on. Milankovitch cycle. Milankovitch cycle has to do with the fact that the Earth circles the sun, I should say, from an eclipse to a sun and back to an eclipse over 100,000 years. The obliquity is the tilt, goes from 24 degrees to 1.5 degrees on a 42,000 year cycle. And then the last one is the axial precession. The axis wobbles around that the Earth rotates on about a 19,000 year cycle. You put all 3 of those together and you get 90,000 years of ice, 10,000 years of warm. What that does is it changes the temperature aspect, which is part of what drives the jet streams and jet stream positions and global temperature. We see that in geologic history. We've had 20 of those ice ages in the last 2 million years. The warm period we're in right now, the last warm period, we call it the Holocene in geology. But if we look at the nice smooth curve we had in that picture, but now look at what we get from the ice core in Greenland. It's not smooth, it's rough, but it still has the same aspects. But notice one thing here. Okay, there it is, right there. Look at the temperature here, but now look at these less temperatures. At no time, the ones before that, the temperature is way up here. At no time is the later temperatures as warm as the previous temperatures. We're moving colder. Next cycle, that was a 100,000 year cycle. The next cycle is only a 500 year cycle, the planetary cycles. Now, some of you may have noticed the Christmas star that came in on December 23rd. That was the predecessor of the warning that we're heading in the planetary cycle. We see it every 500 years. From the birth of Christ and on, every 500 years. But now with Kepler and Galileo and other people on the understanding the planetary movements, we can calculate what the planets are. And what they're doing, the Christmas star was when Jupiter and Saturn got close enough together to look like a star. If you put a telescope on it, you can see the separation, but naked eye, you couldn't. But what that does, it puts those 4 stars, 4 gas giants, at a rectangle opposite Earth. And so Earth is between the sun and those gas giants. And those gas giants have a matter together form a minor magnetic field. The sun has a strong magnetic field. The 2,000 to 3,000 kilometers of the surface of the Earth will be stressed. What that does for us is a couple things. The planetary will give us change the jet stream but it'll change some optical properties in the long run. Because what happens, we get a greater number of earthquakes and volcanoes. And sure enough, these were all the current active volcanoes as of yesterday. And 49 active volcanoes. We're seeing a vast increase in active volcanoes in the last couple of years, and earthquakes. Now, earthquakes are disturbing locally, but volcanoes, if they're at near the equator, can mess up with the whole world. In fact, is Etna over there in Sicily, only pushing up to about 30,000 feet. But we see the ash stream, because of satellites, going clear around the world and coming over Michigan. So disrupting the optical properties of Michigan. And we see that. Nature was very nice to run a little experiment for us. In 1991, the Pinatubo explosion was at the equator in the Philippines, and it put so much ash and trash up into the stratosphere, 40,000 feet, that it blocked the sunlight for 1 year and reduced the temperature of the Earth 1 degree. And then it washed out. But when we go back to geologic history, or archaeological history, actually not archaeological, written history, the Little Ice Age, we see that the greater number of volcanoes indicates a greater temperature drop. And that was the coldest one. So hopefully we don't have a lot of those volcanoes. Then there's the Pacific Decadal Oscillation. The Pacific Decadal Oscillation is a 30 to 40 year cycle of a warm pulse or a cold pulse in the northern Pacific. It's part of the ocean flux. It affects North American temperatures and then translates all around, because the Pacific is the flywheel of the temperature of the world, or Northern Pacific, I should say. So it translates all around the world. So what we see is from 1970 to 2000, we had a warm pulse and global warming all over the place, because we had higher temperatures. As you can see here, up and down temperatures, but the average was warmer. But then in 2000, it switched over to the cold phase. And since then, it's been 0 increase in temperature, or maybe even a slight decrease. But the CO2 is still growing like mad. So CO2 has no effect on temperature. Solar cycles. Solar energy, jet stream, variance, and polar vortex. Now, solar cycles, since we first got telescopes, we've been counting sunspots. And we realize that the sunspots are a lot of sunspots, greater wheat production, warmer. Less sunspots, it's colder. And so we've been plotting them since modern minimum. And we looked at the sunspot cycles, and we realized that sunspot cycle is the same as the solar cycle, 11-year cycle. But why? We didn't have a why. Well, just recently, last couple of years, Valentina Zarkova published a fact, and by the way, if you try to find her literature right now or her publications, it's real tough, because they blocked it because of lack of academic integrity, or I should say academic freedom. It's been blocked by a lot of the politicians. But she worked out the fact that there's a double dynamo of the plasma flux, the shallow and deep plasma flux in the sun. And she realized, doing the mathematics on it, nobody's ever been able to dispute her mathematics. The cycle, as long as they are in sync, things are smooth. You get a lot of sunspots, a lot of high solar activity. When they get out of sync, then they really get disrupted. And the variance is there. And when she throws her calculations over the sunspot cycle, they fit it perfectly. But the interesting thing is they're when in sync, as they are here in the far left, everything's fine. When they get out of sync, things start to get really rough. And we've been seeing this, the results of this in the last few years, and it will get worse for the next few years, settle down a little bit and then get worse again. More plots. And then the last one, which is sort of minor, El Nino, La Nino, it flips over a 2 to 5 year cycle. And that is our expected weather pattern. And this is a nice little, what we call a zonal flow of the jet stream. Nice, smooth, almost a straight line. And this is what we expect to see right now. We should see here in Texas a warmer, drier winter and summer with occasional little rains. This is what we got in February. What we call a meridional flow, a very deep arc. By the way, the one we got coming Wednesday will be deeper than this one. And probably will not bring down a polar vortex because we're getting into a warmer period in the climate period. But this one brought down the polar vortex, as we all know. Basically, we are starting a climate journey. The ice age, minimum 20 to 40 years, 30 years, and possibly as many as 200 or more. That'd be a good question. It will lead to less food production, increased food prices, and famine, disasters, higher energy consumption, and higher energy prices. Why? Well, climate affects one thing: crop production. These are the major exporting countries of the around 2000, 2002. Those in green exported grains, the major producers. The rest of the countries in different levels. We'll see changes. Because now we see what happened. We look at the billion metric tons of exported wheat. 2014, 2015, 2016, 2017 was increasing. Then in 2018, as we see these changes in climate coming in, they start to drop. 2018, we had bad crops in the United States and the rest of the world. And 2019, the same. And I couldn't see the rest. Didn't have time to build the rest of that graph and get the data actually to build the rest of the graph. But I did pull this up. You can see a fact is just over the 2018-19 estimate, 2019-20 estimate, and then the projected down in December, January, significant drop in crop shortage. Exporter stocks. This is for the U.S., the stocks we have to export. Now, a couple of reasons for that major drop: lack of production to replace the stock to export, lack of ability to grow, the problems growing stuff. By the way, when we had that little nice short spell here in February, France lost 1/3 of their grapes froze, their wine crop. And Europe had some big, really major temperature drops. So it wasn't just us, it was worldwide, it's just not reported locally. But we're seeing a situation here. And then China has lost almost all of its crops due to their major floodings in cold temperatures and armyworm infestation of corn. And so they've been buying anything they can buy. And we were shipping them quite a bit of stuff. And also Argentina, due to La Nina, has had a drought. They're the second largest producer of corn and soybeans, and they've had a problem. So China's having a problem. So we've lost a lot of our crops. And then the other thing is, you see the two little pink things here, or three things, I should say. The ones in the middle of it, that's the time of the higher food prices in the Arab Spring. Then things got even, and now it's picking back up again worldwide. Now, part of that's two things: availability of crop and availability of energy, oil and gas costs going up. And it hasn't affected us too much in the United States because we've got a surplus of it. But the rest of the world's paying some significant things. We will be soon. We look at food prices and where they're headed. Now, these are things that you, as an individual, can't really handle much. Vegetable oil, you're kind of going to squeeze out olive oil or grape seeds or rape seeds. Cereals, you got to go grow cereals. But these are increases of food prices over the last, 24, 2016, and they're going up more than that now. But there is hope. One thing is CO2, the increase of CO2 is fertilizing, because that's plant food, is feeding expanding the ability of plants to grow in a drier area. Because the higher CO2, the less water they need. Or I should say they don't. They still need water to grow, but they don't lose water to the atmosphere. And the other thing that we do not see in our general news media is the fact that last Monday, the Sahara had 6 inches of snow. And they've been getting some drastic rains because of change in the aspect of the jet streams in the intertropical convergence zone at the equator and the monsoons, bringing huge rains to North Africa and some of the other areas, and Saudi Arabia, North Africa. And interestingly enough, for you historians, Rome got most of the grain supply from North Africa because that was a good growing area. But for us personally, it's a situation of the commercial farms and ranches are very tied to the elites and the politics, and they will supply the people hurting for food domestically and foreignly before you and I. So the prices of the grocery store go up 400 to 500% in the next couple of years. Large independent farms will somewhat dependent on the federal government for subsidies and stuff. They will, as long as they supplies the Biden's 30-30 policy of converting a lot of that land, their agricultural land, to forests, and also taking them back to instead of being able to put this the term, the price of your land when you want to inherit it, pass it on to your children, will not be calculated as the price when your grandfather paid for it way back when at $20 an acre. It'll be priced at the $2,000 an acre it is today. So they will bankrupt them. For your health and society, try to deal more with your local farm and ranches, get together with 2 or 3 people and buy a beef and have it processed locally. Or as a better situation, if you got enough room, put in a victory garden, your own backyard. Cut as much as your grocery bill as you can in the future so you have money to spend on energy to heat your house. Now, you won't be able to do the grains, Um, Depending on where you live, you might be able to have some chickens or rabbits, but you won't probably have any big animals, and you won't be able to do grains. But you can do some of the vegetables, tomatoes, and stuff like that. Put up your own sauces, stuff like that. If you have questions, hit the chat button, and Dr. eBay will pass it on to me. See how to get out of this. There you go.
All right, very, very good job, Jim.
Okay, thank you. I'm starting to figure out how to stop this share.
That's okay. If you have any question for Jim, could you just post your question or in the chat room? My computer keeps freezing in and out. But again, we thank Jim for his presentation. And if you want to send Jim an email, he gave up his email at the very beginning. You can always send to Jim Mellott, at wc.edu. And I believe the other email of his was jmallott44. Am I correct?
44.
At
jmallott44. My birthday year I was born.
Okay. All right. The question here for you, Jim. The question is from Shelley. He said, what about local food trade?
Yes, no question. One of the sites that my daughter's got me onto is, can't think of the name of it right now, but it's local farmers that imperfect foods. You put in there and say, okay, I want this, 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 and this. And they send you maybe it's not that perfect pepper, but it's still no sort of disformed, but still a good pepper. But they sell it to a grocery store because people going to the grocery store want perfect food.
Okay.
I remember as a kid, my uncles and my great uncles and my dad always had a pocket knife to cut the worm out of the apple, to eat the rest of the apple, throwing it away. But you wouldn't buy an apple in a grocery store with that worm in it. So I mean,
why so?
We just don't do that. We want perfect food. But if you're raising,
and how do you get perfect food?
Used to bring some food in occasionally from my garden into the school there, and I always made sure I brought the stuff that was close to perfect, good shape, and everything else. Now, of course, the little jalapenos, it's always just good stuff anyway. But
sorry, Jim. There's another question for you here. Sorry,
yes.
Before I get my internet keep getting interrupted. The other question for you is: are there any correlations with past climate models and the rise and fall of civilization?
Yes, I showed that. In fact, that was one of the interesting things I've been running into, of all places. Harvard and Yale have been putting together with their history department, ancient history department, and climatologists, looking at the climate change, because prior to the 1800s, in the end, in increase in the industrial revolution, everything was agricultural based. Every society. So they had good crops, the society was doing well. When the crop failed, hey, the king wasn't doing his job. He wasn't talking to God right. And they had revolutions. We see that significantly in the Chinese dynasties. Every time there's been a major crop failure over there, they change the dynasty. It's going to be interesting what happens this one, because they're having real problems right now, climate-wise and food-wise. But that's been true of all other societies. And then anytime you get some disruption, you can tie that to a lot of wars and everything else. When our bellies are full, we're happy people. When our bellies aren't full, we're not happy people.
All right, wonderful.
Mm-hmm.
Any other questions? If there are no questions, we have to Jim. Okay, I don't know if you hear me. Jim can hear me. Can you hear me, Jim?
Yeah, I'm hearing you.
Oh, okay, good. My system keeps freezing, you know.
Yeah, I understand that. I can see that.
Yeah. Okay. So anyways, if our audience don't have any other question for you, maybe we can end the session a little early than normal.
Okay.
Because I don't see any other question coming up. Those were the only two questions. And I thank you and I thank everyone for joining. And again, this session is recorded. If you want to watch it over again, you will have access to it. I believe Scott will be sending the email to everyone on how to access the recordings. Thank you very much, everyone, for attending. And thank you, Jim, for presenting.
Thank you.
Goodbye, everyone. Bye-bye now.